So here we're going to talk about exponents and just kind of some general exponent properties. So I've got this table set up. We're going to fill in this table. I've already got a couple of them in here for you. So this is just saying 3 to the first power. The next one is 3 to the second power, which is 3 times 3, which is 9. So then this next one would be 3 to the third power, which means we just multiply by 3, so we get 27. And the next one would be 3 to the fourth, which is 81. You can keep going, so on and so on. What I want you to notice here is that every time we increase on this table, oops, forgot to grab the pen. There we go. We're multiplying by 3. So 3 to the first, when you multiply by 3, you get 3 to the second. When you multiply by 3, you get 3 to the third, and so on. So if we go the other way, we're doing something times 3 to get 3 to the first. So this is 3 to the 0. Well, what times 3 is 3? Well, that's just going to be 1. Switch over to red here so you can see it a little better. So anything to the 0 power is 1, and that's one. This is one way that people will show why anything to the 0 power is 1 if you continue this table. And then if we do 3 to the negative 1, that means we're basically going to be dividing by 3. So every time you go to the left on this table, you're going to divide by 3. Every time you go to the right, you're going to be multiplying by 3. And so we're just going to keep dividing by 3 here. 1 divided by 3 is 1/3. And then we divide by 3 and we get 1/9. And divide by 3, we get 1 over 27, 1/27. And so 3 to the negative 2 is 1/9. 3 to the negative 3 is 1/27. And one thing, so we're kind of getting into the first exponent property here, is that anytime you have a negative exponent, you can write it as 1 over that. So 1 over 3 to the third would be 1 over 27. Or 1 over 3 to the second is 1 over 9. And so negative exponents, you just rewrite them as 1 over that number. And then you just change the exponent to positive. So let's run through a couple practice ones. If you'd like to pause and try them yourself and see if you can get them, that'd be great. Otherwise, I'll just run through them now, and you can follow along if you'd like to do that. So 2 to the fifth is just 2 times 2 times 2 times 2. And you multiply those all together, you get 32. Nothing super fancy about that one, just doing 2 times itself 5 times. So 4 to the negative 3 is what we just talked about in the previous slide. This would be 1 over 4 to the third, which is 1 over 64. And so you should be able to do pretty much all of these without a calculator. You could do 4 to the third without a calculator. It would be 4 times 4 is 16, and 16 times 4 is 64. The next one is a little bit tricky. And so I'm going to explain how these negatives work here. So this is 1 over negative 3 to the second. We'll start by addressing that negative exponent. We'll pull that down to the bottom, and then it becomes negative 3 to the second. And so this ends up being 1 over negative 9. And you might be thinking, well, wait a second, negative 3 squared is positive 9, because negative times negative. Well, with this one, with order of operations, a lot of times you'll hear PEMDAS. And so order of operations says do exponents before multiplying. And technically this negative out in front here acts as a multiplying by negative 1. So we're going to do the exponent first and then make it opposite or negative. And so we do 3 squared, which is 9, so it'd be 1 over negative 9. Okay, so how is that different than letter D here? Well, this is saying it's pretty much the same thing, except it's negative 3 to the second, so it'll be 1 over negative 3 to the second. And now this is saying square the negative as well. And so this is negative 3 times negative 3, which gives us positive 9. And so the difference between these two is one has the negative 3 in parentheses, which says square the negative. One doesn't, which means you square the 3 first. And then the last one here, negative 4 squared. It's very tempting. A lot of people want to make it 1 over 4 squared to get rid of the negative, but that's only with a negative exponent. And so this just becomes negative 16. Nothing super fancy about that. You just square the 4 and it's still negative. Okay, so we've got some exponent properties. What we're going to do is we're going to do one practice problem, and then we're going to generalize what's happening here. And so if I expand this out, I get it's 3m squared to the 4th, so we're going to write 4 of those. 3m squared, 3m squared. Super inconsistent here, sorry. Times 3m squared. And so I have a bunch of stuff just multiplied together. Excuse me. And actually, I'm going to rewrite it one more step. I'm going to do m squared is m times m. So I'll just write them out. Here we go. 3m times m. 3m times m. So one thing you learned early on in math is that when you're multiplying a bunch of stuff, it really doesn't matter the order in which you multiply that. And so we can rearrange things here a little bit. This ends up being 4 3's multiplied together. So 3 times 3 times 3 times 3. And then let's see, we've got 2, 4, 6, 8 m's. So there's a quicker way to do this other than just writing them all out, but just for effect, I'm going to write them all out. Let's see, there's 8 of them. Yep. So this ends up being 3 times 3 is 9, times 3 is 27, times 3 is 81. So this ends up being 81 with all those 3's multiplied. And then we have 8 m's together, so it'll be 81m to the 8th. Well, rather than writing all of this out every single time and expanding it out, there's a quicker way to do this. And if you notice, we could have taken this 4 and multiplied it to the 2, and that would have gotten us m to the 8th. And then you could have done the 3 to the 4th. And so this, a quicker way of doing this would have just been 3 to the 4th, m to the 8th, which is 81m to the 8th. And so in general, what you do is, in essence, you're distributing that m to those exponents. So this becomes a to the m times b to the m. So whenever you have something to a power, you bring that power into those things, as long as they are multiplied inside there. That's really important. If they're added or subtracted, then it's a lot messier. Then you're having to do what we usually call foiling in the business. But yeah, it's only if they're multiplied on the inside. Okay, let's look at the next property here. So we've got 2 to the 5th, x to the 4th on top, and 2 to the 3rd, x to the 5th on bottom. And so I've got 5 2's on top, and 4 x's on top. And then I've got 3 2's on bottom, and 5 x's on bottom. So whenever we have, if we think about just, basic fractions, if I have 4 over 4, that's just 1. And so a lot of times what you'll see is people just canceling them out. And we're going to kind of do the same thing here. We can cancel out 2's, another set of 2's, and another set of 2's. So it looks like we have 2 2's left on top. And then we can do the same with the x's. We can cancel out a pair of x's, another x on top and bottom, another x on top and bottom, another x on top and bottom, and we're left with just 1x on bottom. And so on top we have 2 times 2, which we can write as 2 squared. And on bottom we just have 1x left over. Or we could write it more succinctly as 4 over x. So that would be simplified down. So in general, what we did here is, if you notice these exponents, let's look at just the 2's here. If we have 2 to the 5th on top and 2 to the 3rd on bottom, we canceled out 3 of those 2's, and there's 2 left. Well, basically what we did is we did 2 to the 5 minus 3. And then for the x's, we did the exact same thing. We did x to the fourth, and we canceled out 4 of those x's, and so it's really x to the 4 minus 5, which gave us -1, which would mean it would go in the bottom. So in general, this is going to be a to the m minus n. I believe this is called the quotient property for exponents. So whenever you have the same base, that's why it's a on top and bottom, and a different exponent, or they could be the same exponent, I guess, technically, you're going to subtract those 2 exponents. So this is called the quotient property. Okay, this one, this one's a little less confusing. We've got 4p's and 5p's, so it's going to be 4p's times 5p's. Maybe should have done this one first. That would have made more sense. How many p's altogether? We got 9 of them, right? So this would have been p to the 9th. So in general, what do we do if we have the same base to multiply together to different powers? Well, this is just going to be a to the, well, what do we do with this 4 and the 5? In order to get 9, we added them together, right? So we get m plus n for our exponent. So it'll be a to the m plus n. All right, a couple more here. So if we have something to a power, and then in parentheses, and then to a power itself, the way we typically will write this is we'll do c squared to the third is c squared times c squared times c squared, which is c times c times c times c times c times c. Well, this is 6 c's all together, and so I can just write that as c to the 6th. And so what did we do differently in this case with those exponents? We didn't add them this time, because 2 plus 3 is 5, so this would end up being c to the 2 times 3, which is 6. And so in general, this would be, if you have a to the m to the n, this would be a to the m times n exponent. And I believe that's called the power of a power, if I remember correctly. And then I think one more. Yeah, pretty sure. Yeah, we're not going to do that one in this video. So if we have 2/3 to the 4th, then we're going to do this 4 is going to, well, let's expand it out. So this is going to be 2/3 times 2/3 times 2/3 times 2/3. If you've learned anything about multiplying fractions, you just multiply across the top. And so we'd have 2 times 2 times 2 times 2 on top. And then we multiply across the bottom, so it'd be 3 times 3 times 3 times 3. And so this ends up being 2 to the 4th over 3 to the 4th, which is 2 to the 4th is 16, and 3 to the 4th is 81. So that becomes 16/81. So what is the in general here? What are we noticing here? Well, this ends up becoming that. So do you see what's happening? That exponent is affecting both the top and the bottom of this fraction. So in general, if we have a over b, some fraction, to the m power, this becomes a to the m over b to the m. All right. So this is kind of a bunch of the exponent properties all in a nutshell here. Hopefully that clarifies some stuff, and we'll be looking at more exponent properties here in the next video.